it's going to look a little bit messy once we get started, but I think once we do a couple examples, you'll start to see the patterns that we're going to have. But fraction busting is essentially just the process of getting each of our terms in an equation to have the same lowest common denominator or least common denominator. Once we all have the same LCD, we can go ahead and cancel all of those denominators so that we don't have any fractions at all. Fraction busting, we're busting the fraction so that it's just a whole number. So let's just go ahead and start with example A. Let's say we have, let's start with something really, really simple. 1/2 x equals let's go through, I don't know, 4/3. There you go. Nice, easy, simple one-step equation here. Thumbs up if you got example A written down, ready to go. Okay, perfect. So we've got 1/2 x equals 4/3. The first thing we need to do is what? What do we have to find first? Just did a whole half worksheet on it. What do we have to find first?
LCD.
We got to find the LCD, right? If we're going to bust these fractions, we have to figure out what our least common denominator is going to be. So step 1 is going to be to find the LCD. Again, we're going to do that by making us a multiples table. So we've got 2 and we've got 3. Those are our denominators. And then for our multiples, we'll go times 1, times 2, times 3. Again, you might be able to identify what the LCD is here right away. That's fine. If you do, you do not have to do this LCD table. This table is only for students who maybe need a little bit more help starting and getting the LCD done. So if you are kind of not really remembering a whole lot from last year, that's okay. That's why we have this table to help us out. And it really helps everyone as we're getting started. But once you get more comfortable, if you can find the LCD just by looking, then you don't have to do all this with the table. But let's go ahead and do it. What are the multiples here for 2 going to be? We'll start with 2. What's next? 4. And then our last one? 6. Thank you, Rashayla. What about our multiples of 3? 3 times 1 gives us 3. 3 times 2 gives us 6. And then what about 3 times 3? 9, right there. And right away we can see, hey, we've got a 6 in the left column. We've got a 6 in the right column. That means that our LCD must be what? 6. There we go. So our LCD is 6. Now we know that we want both of these fractions to have a denominator of 6. So we're going to have to now multiply these fractions by whatever multipliers are going to give us 6 on the bottom. So I'm going to rewrite 1/2 x equals 4/3. Step 2 is going to be to multiply each term. So they have the same LCD. And I'm going to stop right there. I'm not going to write of 6. What are we going to multiply 1/2 by if we want a 6 on the bottom?
3 over 3.
3 over 3. If you don't know how we got that, take a look. We go to the 2 column, because we're talking about the denominator of 2. We look down, we find 6. We look over, hey, times 3. So we're going to take 1/2 and multiply it by 3 over 3. Again, if we multiply that equation by 1, or that term by 1, or 3 over 3, we're not changing anything about that term. What are we going to multiply our second fraction by? Are we also going to multiply it by 3 over 3?
No.
No, that would give us a denominator of 9. So we take a look. All right, our second denominator is 3. If we want this 6 to be our denominator, we're going to have to multiply by 2 over 2. So let's do that. Times 2 over 2. Sure. What do we have now on the left? What does 1/2 become? 1 over 2 becomes 3 over 6. Great job. And what does 4 over 3 become? 8 over 6. Great job, Rochelle. 8 over 6. Do we have the same denominator here now?
Yeah.
Yes, we do. So, now that each term has the same denominator, we can cancel our denominators. When we cancel our denominators, we're going to have 3x equals 8. Canceling our denominators is just getting rid of our denominators. Now, technically, what we did here was we multiplied this whole equation here by 6 over 1. By doing that, we cancel out both of the 6's in the bottom, giving us nice, neat non-fractions in our equation here. Once each and every term, here we only have 2 terms, so we had to get 2 denominators of 6. But if we have an equation with 3 or 4 terms, we have to make sure that all of those terms have the same denominator. Once they do, we can just cross those denominators out and rewrite with whole numbers. Then what we're going to do is solve normally. How should I say this? Not normally. Solve the multi-step equation. This one here is only a 1-step, but we'll build up. So if we want to solve this for x, what are we going to do to both sides here?
Divide.
We're going to divide by what? 3, right? Those 3's cancel out, leaving us with x equals 8 over 3. Can we simplify 8 over 3 at all? No, we cannot. So that's our answer. Don't write it as a fraction. Don't write it like 2 2/3, like a mixed number. We don't want to see that. Yeah, Noah? Yeah.
Right.
How are we feeling about that first example?
Wonderful.
Thumbs up if we're feeling nice and confident. Thumbs sideways if maybe the next example might clear some things up. Yeah, Jordan, you have a question?
No.
Oh, yeah, thumbs up. Okay, good. It's always a coin toss with this lesson, how it's going to go. Either goes really, really smooth or really, really bad. So I guess we'll see once we get started with our work what type of lesson it's going to be. Let's take a look at an example that's going to be more so what we're going to see on our worksheet with example B. Example B, let's go. One half x minus 5/6 equals let's go 5/12. Again, for those of you who are LCD pros, you may be able to look at this and immediately tell what our LCD is. Give me a thumbs up if you can see what our LCD is here right away. Doesn't have to be a super high thumbs up. It can be a small little thumbs up just for me to see. Okay. Can someone explain how they know what our LCD is right away? Because I don't want to have to do that whole table thing. How can we tell? First of all, what is our LCD here going to be?
12.
12, right? How do we know that it's going to be 12? Rochelle, you want to help us out? You're definitely correct. It is 12. What makes you say that it's 12? Because you just multiplied them in your head, right? You said, hey, 2 times 6 is equal to 12. Is that what you're saying you did?
No, I just did like the table.
Oh, you did the multiples table in your head? Perfect. That works. That's definitely one way of doing it. Theo, what do you think? How do we know that that 12 is our LCD?
Because 12 is a multiple of all 3 of those denominators.
That's right. Take a look at this pattern here. We see we've got 2, we've got 6, and we've got 12. So when we have all these different denominators, it's best to focus on your largest denominator. So we take a look at 12. And if you can notice that, hey, 6 is a factor of 12, and 2 is also a factor of 12, that means that 12 must be my lowest common denominator. I'm going to go ahead and do a LCD table just so we can be clear here on what it's going to look like. If we've got 2, 6, and 12, right? And then our multiples will be times 1, times 2, times 3, times 4, times 5, times 6. So here we've got 2, 4, 6, 8, 10, 12. Here we've got 6, 12. And there we've just got 12. All 3 of those denominators, all 3 of those denominators have an LCD of 12. So now we have to figure out what we're going to multiply each of these fractions by to get 12 on the bottom. And we're going to go fraction by fraction by fraction because the number we're going to multiply by is not going to be the same. What are we going to multiply 1/2 by if we want our denominator to be 12? 6/6. Exactly. 6/6. Minus, what are we going to multiply 5/6 by if we want a 12 on the bottom? 2/2. Exactly. And then what are we going to multiply 5/12 by if we want to get a 12 on the bottom? 1/1. We'll add it in there just for consistency to show that you need to multiply by all 3 or all 4 terms, however many we have. Then let's go ahead and multiply these out. What's our first term going to read?
6 over 12.
6 over 12x. Thank you, Rashayla. 6 over 12x. Minus, what's our second term going to be? 2 times 5 over 2 times 6.
10 over 12.
10 over 12. And that's going to be equal to 5 over 12. Notice how we didn't change any of the fractions from the beginning. We still have 1/2 x, and we still have 5 over 6. It's just a proportionally larger way to look at that fraction. Right? 6 over 12 is still 1/2. That's why I said earlier that we were inflating it. We just made it a bigger version of 1/2 so that we could get 12s across the bottom. Now that we have all three of those 12s, we can cancel them out, giving us a new equation that reads 6x minus 10 equals 5. This is why we're doing this fraction busting, because we still need to solve for x. Our goal for this lesson is the same goal as our previous 4. We still want to find x, getting x all by itself on one side. When we have all these fractions, it makes it almost impossible to do so unless we bust the fractions out first. Because now we have a nice simple 2-step equation here in which our first step to solve for x is going to be to do what? Split our equal sign. What are we going to do first here? There's no way we forgot all that from last week, right? We're going to do what, Theo?
Add 10 to both sides.
Add 10 to both sides. That sounds good to me. These 10s cancel, leaving us with 6x equals 15. And then what's our final step going to be? Divide by 6. That's right. When we do so, these 6's cancel to 1, and we're left with x is equal to 15 over 6. Can we simplify 15 over 6 at all?
Yeah.
I hear some no's, I hear some yes.
No.
Well, they're both divisible by 3, right?
No. Forgot 3 was a number.
15 is 5 times 3. 6 is 2 times 3. I'm going to move this down a bit so I can zoom in.
5 over 2.
That's right, we cancel these 3's out. And all we're left with is x equals 5 over 2. I want to do one more example, then we'll get to work here. If you don't have any room, just go on to the next page. That's all right.
Right there.
I ran out of room myself. Example C.
What the heck?
Stop looking at me. He took our star.
Huh, Jordan?
X plus.
Is up.
Okay. Let's try this example. Right off the bat, what's something we notice about this example that's a little different than the previous two examples?
There's a variable.
No, it says there's a variable. Well, we had 1/2 x over here.
Oh, I meant like,
We had 1/2 x up here. What's different about that variable, though?
there's no fraction.
There's no fraction in front of it. Beautiful. Let's go ahead and write this as a note. X has no fractional
Okay, I'm sorry, Jordan.
coefficient. What number can we put in front of x as a fraction, though, just so we have a fraction in front to use? 1
What are you doing in my back?
over 1. Exactly. We're going to go ahead and put 1 over 1 in front of our x, just so we can have all 3 terms set up as fractions. You're going to have to do that quite a bit on our worksheet, so make sure you understand what we're doing there. Now we got to find the LCD. 3 and 8. This one's a little bit trickier, right? Some of us. If we wanted to go ahead and set up, actually we got 1, 3, and 8. Technically, right? We've got 3 denominators. 1, 3, and 8. So, when we have something like this, if we're asked to find the LCD, here's what I would recommend you do, because you might, if you get comfortable with the multiples table, you might run into a problem where it's not really that helpful to do a table because you're going to have a super, super long list of numbers. Like this one. So when we're tackling our multiples table, if you want to use a multiples table, here's how I recommend you do it. Start with the largest of the 3 denominators, 8, and only focus on that one. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, and 8 times 4 is 32. Now you're going to take a look at those 4 multiples and ask yourself, which of those is divisible by the next smallest denominator? 8's not divisible by 3. Is 16 divisible by 3?
No, 24.
No. Is 24 divisible by 3?
Yeah.
Yes, it is. 24 is going to be our LCD. Yeah. Yeah. There you go. So if we wanted to do this, we'd have to fill in all these spaces just to get down to 24 for our 3. You see how doing all this work isn't very conducive to us finding an LCD nice and quick?
Yeah.
So I would just say focus on the largest number and then find the smallest multiple divisible by that second smallest number. So our LCD here is going to be 24. That's good to know. What are we going to multiply each of these fractions by? Let's start with this first one, 1 over 1x. What are we going to multiply by 1 over 1 if we want a denominator of 24? 24, right? Over what? 24. We always want to multiply by a whole fraction because then it's just multiplying it by 1. What are we going to multiply 2 over 3 by?
8 over 8.
8 over 8. And then what about 7 over 8?
3 over 2.
It's going to be 3 over 3, right? If we want 24 on the bottom, we've got to multiply 8 by 3. We multiply all those out, we get 24 over 24x plus 16 over 24 equals 21 over 24. Let me ask you this. How many total terms do we have in this equation? Go ahead and show me on your hands real quick. How many total terms do we have in this equation? Good. I see a couple people over here. Anyone in the middle want to take a guess how many terms we have in this equation? No, just going to stare at me? Okay. We got 3 terms. We got this term here. We got this term there. And we got this term at the very end. 3 total terms. And we see that we have 3 denominators of 24. Once we see that all of our terms have the same denominator, we can go ahead and bust those fractions and cancel out our denominators, leaving us with 24x plus 16 equals 21. Give me a thumbs up if you guys see what we're doing here. Okay, good. Now we solve this like normal, split up our equal sign. We're going to start by subtracting 16 over to the right, leaving us with 24x equals what? 21 minus 16? 5. And then what's our last step to getting x by itself? We're going to divide by 24. Can we simplify 5 over 24 at all?
No.
Nope. So that's just going to be our answer. So with this work, because we're dealing with fractions, this is a strong possibility you're going to get very ugly answers at times, just like this, 5 over 24. A lot of times, it's first instinct when you get a fraction that can't be simplified as an answer. A lot of times, students immediately think, oh, my answer now must be wrong. 5 a fraction that I can't simplify. It's not always the case. Like I always say, if you're confident with the procedure, with the steps that we're taking each time, you may get an ugly answer, and that's fine. As long as you're confident in your steps along the way, don't second guess yourself. You should be okay. All right? We got 8 questions on the worksheet today. Not too bad, because they are